Factoring. Factoring, factoring, factoring. So when we talk about algebra, factoring never goes away. And when we talk about factoring, we are talking about factoring what are called trinomials. And that is factoring when you have three different things that are added together. So a trinomial is of the form ax squared plus bx plus c. And when we factor this, the first type of factoring that we're going to look at are factors of the form where this a value is just a 1. So I'm going to erase that a value, because if there's nothing there, that means there's just a 1 out in front. So the factors of this, right? So the factors are x plus m times x plus n. And even though I use pluses there, we'll talk about different signs for m and n as we talk about the different possible signs for b and c. But the factors are x plus m times x plus n, where m times n must equal c, and m plus n must equal b. Now again, notice this only works when this lead coefficient is a 1. So let's look at a couple of examples where we are factoring with a lead coefficient of 1. So we have x squared plus 8x plus 16. And we are now looking to factor that. So that's going to factor to x plus something and x plus something else. The question is, what numbers go here and here? So we know whatever those numbers are, when we add them together, we must get 8. And when we multiply them, we must get 16. Now you do not have to go through this long process I'm about to show you every time, but here's the idea. So you have 1 times 16, 2 times 8, 4 times 4. Those are the only three ways to multiply and get 16. 16 plus 1 is 17, 8 plus 2 is 10, 4 plus 4 is 8. So I'm looking for two numbers, and notice they can be the same number, where when I multiplied them together, I got that back number of 16. When I added them together, I got the middle number, that is 8. So what I have is x plus 4 and x plus 4 again. That can be written as x plus 4 quantity squared. Now it says find all real values such that f of x equals 0. So if I take this thing and I set it equal to 0, I take the square root of both sides, and that would give me that x plus 4 equals. Now, I told you in a previous example, if you take the square root of something squared, you need to put plus and minus, but plus and minus 0 is just 0. So we're going to put a 0 there. And subtracting 4 from both sides, x equals negative 4. So we factored it, and then we used that factor to solve the equality in the next part of the problem. All right, so now we're going to factor x squared minus 7x plus 10. This time, notice that this sign is different. In the last problem, we had two positives. Now we've got a negative. Well, let's just say that if this sign is positive, then both factors have the same sign. And that is the sign of the factors, because they're both the same. This time they are both going to be negative. So the fact that this sign is positive tells us that both factors have the same sign, and then this front sign tells us what the sign of those two factors is. So in this problem, we will take that, and that lets us know that we are looking for x minus something, and then x minus something again. Now again, I'm going to belabor this a little bit, but if you get this quicker, you do not have to show all of these factors. But how do I get 10? 1 times 10, negative 1 times negative 10, because remember we're looking for negative numbers, 2 times 5, negative 2 times negative 5. Those are all the different ways that you can get 10. Now notice that the signs of both of those in all four cases are the same. Well, since I know that we want negatives, I can immediately throw out those two. Negative 1 plus negative 10 is negative 11. That is not negative 7, so I can throw that one away. Negative 2 plus negative 5 is negative 7, so my 2 and my 5 go there. Next, we are asked to use that to solve the equality. So x minus 2 times x minus 5 equals 0. There is a property in multiplication called the zero product property. And it says that if two things are multiplied together and the answer is 0, one or both of those original two things must be 0. So in order to find out the answer to this, we can take x minus 2 and set it equal to 0. That means that x equals 2. And we have x minus 5 equals 0, which gives us x equals 5. Now I'm just going to take one of these and plug it back in so that you can see. If I were to plug that 5 into my original trinomial, I would get 5 squared minus 7 times 5 plus 10. 5 squared is 25 minus 7 times 5 is 35 plus 10. 25 plus 10 is 35 minus 35 gives me 0. The same thing would happen with the 2. If I were to take the 2 and say, all right, 2 squared minus 7 times 2 plus 10, that would be 4 minus 14 plus 10, also 0. So either one of those two numbers would give me the 0 that I am looking for. Okay, now we have x squared minus 2x minus 15. And let's look at how this one is different. This time, notice this sign is negative. When that sign is negative, that tells us that the factors will have opposite signs. All right, so negative number means the factors will have opposite signs. The fact that that is negative tells us that the larger factor will be negative. So let's set up the problem, see what we've got. So we're going to have x minus something, and we're going to have x plus something. Different signs because that back sign is negative. How do you get 15? Negative 1, positive 15. Positive 1, negative 15. Positive 3, negative 5. Negative 3, positive 5. Any one of those sets will work to get the negative 15. But I need them to add up to negative 2. Not that, not that. Negative 3 plus 5 is positive 2. Positive 3, negative 5. So I put the 5 there, the 3 there. And then to solve the next part, where I take that and set it equal to 0, x minus 5 x plus 3 equals 0, x equals 5, x equals negative 3. Okay, final type of this particular problem is when we have a negative in the back, and we already said that negative in the back means opposite signs. The positive up front means that the positive is larger. So this problem is really not much different than the last one that we did in that it's the opposite sign, but we will find that whenever it's opposite sign, this will tell us the sign of the bigger one. At this point, if you see the answer, you can just put the answer. You do not have to break it down like I am every single time you do it. It's very time consuming to list all the different factors and do the problem the way that I'm showing you. It works every time, it's just time consuming. If you see right now, all right, 3 times 7 is 21. The 7 would have to be the bigger one, so that would be 7 and 3. The 7's big, the x is small. Bam, you're done. I mean, that you are allowed to, it is okay to do it that quickly. Now, if you need to go through and say, all right, negative 21 and 1, and 21 and negative 1, and 3 and negative 7, and negative 3 and positive 7, and now I'm looking to add to 4, that doesn't add to 4, that doesn't add to 4, that doesn't add to 4, that one added to negative 4, there's the one that works. You can go through that every time. That's the mental process that you're doing, but feel free to skip the steps. Don't always skip steps, but that one in particular, you don't have to do this setup every single time. We get to this point, and now we've got x plus 7 equals 0. We take the thing, set it equal to 0. X plus 7 times x minus 3 equals 0. X plus 7 equals 0, so x is negative 7. X minus 3 equals 0. X equals positive 3. I'm going to stop this video here and go on to part 3 because in the next couple of problems we're going to be looking at a new methodology, and I don't want to run out of time, and I only have 15 minutes because that's all YouTube allows me. So I will see you in the next video. That's a lie. I won't see you in the next video. You will hear me in the next video.